Okay.
Okay, so this is managerial economics, and these are the trial questions. We are solving question one. So quickly, we move to the requirements. And the requirement says we should write out the estimated demand model. This question mostly is a regression, and it's similar to research methods regression analysis. We should interpret the coefficient of the estimated demand model, interpret the adjusted R squared. Then the C says um, we should, if PX equals 5, M equals 100,000, advertisement equals 10,000, PS equals 2, and PM equals 50, determine how many units of Mike Pizza will be bought. All right, so the question continues to N. So this is the passage where we have Mike's Pizza to be the QDX, Mike's Pizza's own price to become the PX, the price of Sprite become the PS, Max Pizza becoming the PM, and consumers' income becoming the M, or income of its consumer becoming M. We then also have the model, right? The model for the demand, which is this. So in other words, the model we are going to write, the equation we are going to write, should pattern after this model. So after collecting the data on the regression variables, the regression model was estimated and the results are presented below. We have the summary output, multiple R squared, adjusted R squared, standard error, observations, and we have the analysis of variation, and we have the regression residual, we have the coefficient, standard errors, T stats, p-value. So we will start the A. It says we should write out the estimated demand model. Now, the main product in question, which is the QDX, refers to the demand for Max Pizza. So we would write it out by saying the QDX equals, then we start with the intercept. So which is written first, followed by the next coefficient, which is a negative coefficient. Then we'll multiply it by, that's written down here. We multiply that coefficient by the px, which is written over there. Then the next coefficient is positive 4.998, which is written over there. And it will multiply by the corresponding variable. So sometimes we can call the intercept column as variables or parameters. So whichever one will be written, we are okay with it. Okay, so we move on to we move on to the PS. That's the advertisement. So we have the advertisement to be, 7.2047, which continues below. 7.2407 over here, multiplied by advertising or advertisement or amount of advertisement, then followed by the negative 4465.5353 PS multiplied by the PS. And the last one is multiplied by the PM. So that's our model written. Now the B says we should interpret the coefficient of the estimated demand model. Since the question says we should interpret the coefficient, it means I'm going to interpret every coefficient written there. Assuming the question had said, interpret the variables. These are not the coefficient, but the variables. It means you're only going to cater for the PX to PM. That's what we're going to cater for. I good. That's what we're going to cater for and interpret. But it says you should interpret the coefficients, meaning the intercept is inclusive. Okay. So let's start. So the first, is the QDX, which says that when all QDX, we equate QDX to that's 3,721.0148, and says when all the independent variables are zero, demand for Mike's Pizza is 33,721.0148. What it means is that in the event in the event the variables, that is PXM advertising and PX here, in the event the PX is zero, M is zero, PM is zero, PS is zero, advertising is zero. If all these variables are changed to zero, and we multiply them by their corresponding coefficients which are attached to them, it will turn the whole term of the equation to 0, 0, 0. So we are going to be left with 33,721.0148 minus 0 plus 0 plus 0 plus 0 plus 0. So in all, it's going to be QDS equals 33,721.0148 plus 0, which will give us the 33,00148. So that's the interpretation for the first one, the QDX. That is the interpretation for the intercept. We move on to the interpretation for the PX. Looking at the model we wrote, the demand equation we wrote, what is the coefficient of the PX? It's negative 260.6820. So we've written over here, we have PX equals the coefficient, but the negative wasn't introduced. The negative wasn't introduced. You can choose to bring the negative, which is correct, or choose not to bring it. But let's write it this way. So I will introduce the negative. Negative 260 260.6820. It says a unit increase in the price of Mike's Pizza will cause demand for Mike's Pizza to decrease by the coefficient. Decreasing because the coefficient is negative. So it will decrease. There are several ways I can write this portion. There are other ways I can write it. So however you write it, it must establish the effect of the variability, right? The variability in the variables, and also the impact of the variability on the dependent variable. So here, demand for Mike's Pizza is a dependent variable. The price of Mike's Pizza is the independent variable. So the variability, that's the change, whether it can increase or decrease. Mike Pizza, the price of Mike's Pizza increasing or decreasing, which is the variability, having an effect on the demand for Mike's Pizza. So basically, all that we are going to do is the interpretation is such that we are going to pick each of the variables and how they have effect on demand. So from the demand equation model I've written at the top, we want to we want to see how each of the parameters I mean to say this parameter, the intercept parameter, the price parameter, the consumer's income parameter, the adverse, how each of them have impact on demand when they vary when they increase or decrease. Okay, so all the narration we are going to make is based on the impact or the variability of the variables with their effect on the demand. Are we okay?
Yeah.
Are we okay?
Yes.
All right, so let's move on to the next variable. We are looking at income, right? That's the third one, M. The coefficient is 4.9928. So I come in here. If you don't understand anything, ask me. You asked me the question. 4 points. So that's M. So M equals 4.9928. So the interpretation is very simple, not anything difficult. 4.9928. Then we bring the column. 4.9928. So now let's look at something here. Just something quick, something very quick. For all the remaining interpretations you're going to make, I'm not going to write all of them, but this is the clue. For all the remaining interpretations you're going to make, you only will change what I'm going to underline. So I'm going to base on the PX to make changes to the subsequent interpretation. So if you understood the PX interpretation, and with the example I'm going to give, you should be able to interpret all, because I'm not going to write all of them. But it's easy. It's so easy. So now I've written the variable, which is the M, with the corresponding coefficient, which is 4.9928. You repeat for all the respective variables: advertising, price of sprites, price of max pizza. Repeat for each of them. But the only thing which will change in terms of the interpretation, when you look at the PX, are what I'm going to underline. So number one, the name will change. The variable in question will change. So the price of max pizza will change. Now, decrease, the word decrease will change, because sometimes, like max pizza, for the consumer income has a positive coefficient, so you cannot say it is decreased by. You only have to say it's increased by. Then we also have this figure is going to change. So in all the interpretations, the only terms to change are what I've underlined in the PX. So when I go to, let's say I'm taking the consumer's income, so M equals 4.9928. A unit increase in, so you could see that I've repeated the same interpretation, the first part, as is for the price. So a unit increase in, here instead of saying price of X or price of Mike's Pizza, because I'm dealing with the variable income, consumer's income, I would say a unit increase in consumer's income will cause demand for Mike's Pizza to increase. Increase because the 4.198, which is the consumer's income's coefficient, is positive. So we can see here that it is positive. So it is positive figure. So that's why it is going to increase. But with the price of X, we saw that the coefficient was negative, or the coefficient is negative. That's why for the price of pizza, the price of Mike's Pizza, we said it will decrease. It will cause demand for Mike's Pizza to decrease. But here, because consumer's income is positive, we will say it will cause demand for Mike's Pizza to increase by 4.9928, all things being equal. So I'm going to say for the last time the correct way. A unit increase in consumers' income will cause demand for Mike's Pizza to increase by 4.9928 units, all things being equal. There are several ways you can write this. A 1 unit increase in this would cause a 1 unit increase, or a decrease in demand for Mike's Pizza by 2.60.6820 units, all things being equal. That's one way you can write it. Or a unit change in the price of Mike's Pizza will cause demand for Mike's Pizza to change by two, sorry, okay, let me use the consumer's income rather. A unit change in the price of, any change in consumer's income will cause demand for Mike's Pizza to change by 260.6820 units, all in the same direction, all things being equal, or holding all other factors constant, or holding other factors constant. So there are different ways you can write it, but it should, no matter what you write, it must show the variability in the independent variable, which will cause an effect on the variability of the dependent variable by the number of units. Okay, so it's the same thing you repeat for the advertisement. The advertisement is the same thing you repeat for the price of Sprite. The same repeats for the price of Mike's Pizza. Are you okay? That's it. Are we good? Are we good?
Yeah.
All right, so we are done. We are done with the B. Let's move on. C. Interpret the adjusted R squared. Okay, interpret the adjusted R squared. So who can help us with what the adjusted R squared stands for? Interpret. Okay,
Looks
so we're on
like
C. Question C.
Amy is off. Okay.
Okay, so we're solving the question C. We're on question C. So let's see what question it says. Interpret the adjusted R squared. So this here is adjusted R squared. That's adjusted R squared over there. We'll pick the value, which is 0.9938. So that's C. C.
Oh, you what? Sir has left it.
They're recording. But it's still recording. No.
Let me keep quiet.
We are talking.
All right, so we're on C. C says we should interpret the adjusted R square. And we learned that the adjusted R square is 0.9938. So as better you write adjusted, right, R squared, which equals 0.9938. We multiply by 100%. We have 99.38%. All right, so the interpretation is that 99.38% of the, you can use the word variability, right, or variation of the variation, or you can use variability, the variation in the dependent variable. What's the dependent variable? Demand for Mike's Pizza. That's the dependent variable. The demand for Mike's Pizza right? It's explained. It's explained it's explained by other factors apart from, right? It's explained by other factors apart from, we have price of Eddie's Pizza, consumers' income, advertising, amount of advertising, we have price of Sprite and price of Mike's Pizza. But you write them in full. The price, the variables I've written, the abbreviations I've written, write them in full, not with their symbols or their abbreviations. Very good. So 99.38% of the variation in the demand for Mike's Pizza, because that's the dependent variable, is explained by, okay, so you have to put in something here. It's explained by the variation. Okay, let me clean something here. I'll continue. It's explained by the, all right, by the variation, I got variation, that's variation in other factors, right? Variation in other factors. Apart from price of Eddie's Pizza, price of Mike's Pizza, consumers income advertising, price of Sprite, and price of what? Max Pizza, right? So don't forget to bring that. Are you good? Are you good?
Yeah.
All right, let's continue. We have D.
Sir, please, can I ask the question?
Okay, so that's for answer C. Let's move on to the other. We are on D. Let me bring D up here. Okay, what is D saying? D says if PX equals 5, M equals 100,000, and advertisement is 10,000. So let's see what we can do about that. Let me bring this one here. Whenever I need it, I'll just keep it there. So it should come down here. Okay, so we're on D. Let's go to D. D. Now, if dx, for I have to repeat the equation we wrote for the A, which was the QDX, because I'll need it to solve this equation, equals, what was the value for the,
33,
okay, call them out for me.
the
You have them, call them
coefficients.
out. Yeah, 33
33,
or 33,000.
721.
Hold on.
33. Sorry.
Mm-hmm. 33,721.
33,721.0148
Mm-hmm.
minus 260.6820 px.
0.6820 px. Okay.
Yeah. Plus 4.99
Mm-hmm.
28m
Mm-hmm.
plus 7.2047
Plus 7.20.
2047
Mm-hmm.
advertising
Mm-hmm.
minus 4465.53 ps
Mm-hmm.
plus 112.6921
Hold on. Let me write it down here. Plus 112.6921.
6921 pm.
All right. And the question says, what is here? It says px equals 5. So px equals 5. M is 100,000.
Yes.
Advertising is 10,000. Then PS is 2, PM is 50. PS equals 2, PM equals 50. All right, and it says we should, what's the question? Determine how many units of Mike pizza will be bought. So simply, it wants to find, since it wants to find the demand, what is the quantity demanded? So in other words, the question wants us to find the QDX. So we just repeat the QDX here. Because that should determine the quantity of Mike's pizza that will be bought. So it wants us to find the QDX, which is the demand quantity. So I'll repeat the same figures in the model, but each time I reach the variable, I replace the variable with a value. So 33,721.0148 minus 226. My tree is not properly writing. Okay, you call that for me. Minus 260 point what? 6820. Is that correct? Is that
Yes.
correct?
Yes.
Times PX is 5, right?
It's
Followed by
5.
what?
Yes.
Followed by what?
Plus 4.9928. 100,000.
4.9928. Is that consumer income? Okay. To bracket
Yeah,
100,000.
that's income.
What else?
Plus 7.2047.
Multiply by what? Advertising, right? Amount of advertising,
10,000.
10,000.
Yes,
All right.
10,000 minus
Mm-hmm.
4465.53 multiplied by 2.
4.65.5353, right? Multiply by 2.
Yes.
Okay, so give me the final
No,
answer.
only 53, not 253. So please, not 253. There is another one plus 11.
Hold on. Check the PS here. Check. Have you seen it? The 5 threes are repeated.
5353. Okay,
Yeah.
okay. Thank you, sir.
Okay. So what's the next one?
Plus
Plus.
112
Mm-hmm.
0.6921 to bracket 50.
That's it. So multiply. You should add everything and give me the final answer.
595.
A moment. Mm-hmm. 595.
448.
I believe the figure is accurate, but the others can also confirm it. 559.
595, not 559.
595.
448.
Mm-hmm.
0.1392.
Okay, that's fine. So that's then you make it units, right? The units against it. We are done. Let's go to the E. Comment on the assertion that Mike Pizza is an inferior good. Okay. So we continue with E. Comment on the assertion that Mike's Pizza is an inferior good. So the first concept is that we come to, what is the first equation? Okay, the QDX. We are back to the QDX equation. That is D. I've written the first equation there. Okay. So the question is we should comment on the assertion that Mike's Pizza is an inferior good. You must always look out for the factor, the demand factor, which causes or which can enable a good to be determined as inferior or a non-inferior good. Let me put it that way. So the good can be a normal good or an inferior good. So which factor of demand, right, can enable us to determine whether a good can be inferior or a normal good? Yes, which factor of demand?
Income.
Good. So you quickly, with this question, it's a straightforward answer. Mostly it's a 1 mark question. It's a 1 mark question. So you quickly go to income. Go and check income. Okay. So you come to income. Then when this income, this will help us this will enable us to determine whether a good is inferior or not inferior. And the question says, comment on assertion that Mike's Pizza is an inferior good. So look at this. The coefficient of income is positive, which is the same as in the question. So this income, the coefficient of income is what? Positive.
Positive.
Good. So we go on. So the question is saying that comment on the assertion that Mike's Pizza is an inferior good. So is Mike's Pizza an inferior good indeed?
No,
Why?
because the coefficient of income is positive.
Good. So that assertion is a false or wrong assertion. So we'll say Mike's Pizza, or we can say the assertion that, let me write it that way, that'll be more formal. So the assertion, right? So the assertion that Mike's Pizza my Z somehow. Mike's Pizza is an inferior good, right? Is false. Is false. Okay. My screen is slippery. So we can explain further. This is because, okay, it's flowing now. This is because the coefficient of income or consumers' income, right? That's consumers' income. Consumers' income is positive. Right? Making Mike's Pizza a normal good. Making Mike's Pizza a normal good. That's it. So that's it. Are you okay? So the assertion that Mike's Pizza is an inferior good is false. This is because the rate of consumers' income is positive, making Mike's Pizza a normal good. Are you good?
Yeah.
Are you good? All right, let's continue. So let it be here. I'll switch there. Okay. The next question says, how does Mike Pizza relate to Sprite? How does Mike Pizza relate to Sprite? Okay, so let's go. Let's go and check there. Mostly, or I should have gone to the question A, the requirement A, but because I've cleaned it, I'm using the equation. I'm using this equation to solve it. This equation, which is a model, which I wrote in question A. So I'm having it here. So I'm looking on it. Ordinarily, you have to look at the A. The A contains the same regression model, the equation. So it says, the question says, let's see the question again. The question says, how does Mike Pizza relate to Sprite? How does Mike Pizza relate to Sprite? Okay, so you have to look at Sprite, and I'm using yellow to find what's Sprite's equation. I'm using yellow. Let's put it that way. So this is Sprite. This section is Sprite. I'm using gold color, right? That's the gold. That's Sprite. So how does Mike's Pizza relate to Sprite? So we would say that price or the price of Sprite or Sprite I get is complementary. That's the relationship. Or the price of Sprite negatively relates to, right? Negatively relates to the demand for Mike's Pizza, or negatively relates to Mike's Pizza. It's the question says, how does Mike Pizza relate to Sprite? So Sprite, right? Sprite negatively relates to what? Mike's Pizza, making Mike's Pizza a complement. So that should be the F. That should be the F. Let's write it. I'm taking my time very much so that we can grasp the concept. F. Sprites, right? Sprites. So are you following? Pearl.
Yes, sir. Yes, sir.
Negatively relates to what? Mike's Pizza. So I'm reading it. If you, in the email, you cannot see Mike's Pizza. Mm. Mike's Pizza. That's a Z, right? Making them complementary goods. Making them complementary goods. Making them complementary goods. All right. So Sprite negatively relates to Mike's Pizza, making them complementary goods. That's all. Let's move on to the next. So we're on F, we're on G. We'll finish soon, eh? We'll finish soon. Then I'll start with question 2. G. G says, how does Mike Pizza relate to Max Pizza? So the same concepts. We just go to Max Pizza and look at the coefficients. So Max Pizza is, I'm highlighting in green. Here is Max Pizza's term of the equation here, the green highlighted. So we also look at the sign, it's positive. It's positive. So if it's positive, then it means that it positively relates to, so Max Pizza, Max, one is Mike, which is the main equation, the demand one, and there's Max. So Max Pizza, right? Positively, when I want to write quickly, my screen becomes slippery. So let me take my time. Max Pizza, positively, right, relates to Mike's Pizza, which is the main equation. Mike's Pizza, the main demand. Mike's Pizza. Making them substitutes. Making them substitutes. Are you good? Are you good?
What's up?
Yes.
All right, let's move on. H. At a level of significance of 0.05, determine which of the variables are significantly significant. At a level of significance of 0.05, determine which of the variables are statistically significant. Okay. So H. So what we'll say is that we'll start with a rule. A rule. If. Now, with this question, let me come here so we can get something right. With this question, because the question has already given us p-values, just like research methods, we will compare the significance level, right? We'll compare the significance level with the p-values to determine the significant and insignificant variables. So because you have the p-value, that's the approach we'll go with for this. So let's get to it. Okay, so the rule is if p-value is less than, that's p-value, right? It's less than significance level, there's a more standardized way of writing it, but let me use this one, which will be easier. We don't spend so much time here. If p-value is less than significance level, what do we say? We say statistically significant. Statistically significance. Significance. Then the second rule is if p-value is more than significance level, that's significance level, right? We say what? Statistically insignificance. Insignificance. All right, so that's the rule. So we go. So I'll start with variables here. Right, I'll start with variables here. Then I'll come with the p-values. All right, the p-values. Let me write it this way. Then I'll come with significance level. Now I'll come with conclusion. Okay. All right. So what are the variables we have? I will not include the intercepts. So I have px, I have m, I have m, I have the advertisements, I have the ps, I have the pm. All right, good. Then the significance level is 0.05. So we'll maintain it for all of them at each level. 0.05, 0.05, 0.05, 0.05, 0.05. Okay, then let's go in for the p-values. So the p-values. Okay, so where I've highlighted green in a circle, the p-values I'm going to pick up. So we have 0.1088, then 0.001. Okay, let me go and write it for the 3. So I have the p-values here. I'm writing it in blue. 0.1088. We have 0.1231. We have 0.1234. Okay, we are left with 2 more. Then we have 0.0308, 0.6605, 0.0308, 0.6605, 0.6605. So we have 0.0308. We have 0.6605. Good. So you're done. Now you compare with the rules we've written. Is the first one 0.1088 against 0.05. So you're gonna have something like this. 0.1088 and we have 0.05. So we are comparing both to see which one is higher. So 0 for the p-value, 0 for the significance level. We have the points for each of them. We have 1 for p-value. We have 0 for the significance level, right? So we say that the p-value is greater than 0.05. And what does the rule say? Or what does the rule say? The rule says that if the p-value, the second rule, if the p-value, this one, if the p-value is more than the significance level, statistically significant. So, sorry, statistically insignificant. So we come here, and since the the p-value is more than it, we say that statistically, so I'll write it in short, statistically what? Insignificant. Statistically insignificant. Then we compare the next one. I'm using red. 0 for p-value, 0 for significance level, 0 for p-value, 0 for significance level, 0 for p-value, the third digit 0. Then we have 5. So this one satisfies the first rule. The first rule says p-value is less than significance level. So statistically significant. So because the variable m, has a p-value less than significance level, we say statistically significant. Are you getting it? Then advertising, the same, statistically significant because the p-value is less than. Then we have the PS. That is, so we have 0 p-value, 0 significance, 0 p-value, 0 significance, 3 p-value, 5. So that is also statistically significant. All right, the last one. The last one, we would say statistically insignificant. So statistically insignificant. Are we good?
Yeah.
Yes, sir.
So the question says that we should the question says at a level of significance level, determine which of the variables are statistically significant. So we come. Now you're not going to find it. You always put this in a table, make it in a tabular form. All right. So we say that at 0.0 or at a level of significance of 0.05, at a level of, right, at a level of significance of 0.05, which of the variables are statistically significant? The remaining four, right? Other than the px, sorry, these three are significant. These three are statistically significant. So we say that at a level of significance of 0.05, m advertising and price of Sprite please you write them in full. You write the variables in full. Don't write write consumers income. Don't write ADV, rather write advertising. Don't write PS, write price of Sprite. Consumers income, advertising, and price of Sprite are statistically significant. All right, so that's it. Let's write it quickly. Significant. All right, so let's move on to the next question. Comment on the overall significance of the model. I. Comment on the overall significance of the model. So we come in with I here. So I. Now let's go back to the first document. We need to pick an information from there. Okay. So to comment on the significance of the overall model, we use the F and its corresponding significance F. We are going to compare the significance F with the significance level. Significance level, right, of what? The significance level of 0.05. The significance level of what? 0.05. So to determine if the same rule, if the significance F is less than the significance level, if the significance F is the probability value for the F. If it is less than significance level of 0.05, then we say that the overall model is statistically significant. However, if it is small, then we'll say the overall model is statistically insignificant. Okay, so let's get it done. So the value is 0 point and then 4 decimal places of 4 zeros. Okay, so the question says, I comment on the overall significance of the model. So the model, right? The model is, or we'll say the overall model is statistically significant. The overall model, the overall model is statistically significant because the significance F into brackets, right? The significance F into brackets 0.0000, 4 zeros, right? Is less than the significance level. It's less than the significance level of 0.05. That's it. So the overall model is statistically significant because the significance F, the bracket 0.001, is less than the significance level of 0.05. We are done with I. Any question?
No.
Any question?
No.
All right, so we are done with I. Now we proceed to J. It says derive the demand curve for Mike Pizza. Derive the demand curve. So we go, J. Now we'll go back to the equation, the D equation, right? Where's the D equation? That question D. Good. The very equation, the model, the demand model or the demand estimated equation or estimated demand equation, which I've circled. We are going to change every value there, right? Except PX. All the variables are going to be changed. The M adverts, right? The M adverts, PS and PM are going to be changed with their corresponding values. Are going to be changed with their corresponding values. Or are going to be substituted with their corresponding values, but the PX will not be changed. So we will maintain the PX. All right. So let's see what we can do to that. Okay. All right, so I'm going to repeat it again. All right, so QDX equals, what's the intercept? We have 3, 3, 3, 3, 721.0148. Then we have minus 260.6820 px. That will then be changed. Then we have plus 4.9 plus 4.99 28 m, then plus 7.2047 advertising. Then we have minus 4.4465 0.5353 PS. Then lastly, we have plus 112.6921. Okay. So now the question says that we should, right? The J says we should derive the demand curve for Mike Pizza. So we're going to repeat the same equation, which is the QDX equals, by the time around, it says 3, 3, point 721.0148 minus 260.6820 px, right? Px. Then plus, okay, so this we're going to change it. Plus 4.9928. And M, what is the value of M? M is 100,000. We're going to change the 100,000. 1, 2, 3 plus 7.2047. Advertising is 10,000 minus 4.4465.53 to bracket PS. And our PS is 2. Then plus 112.6921 to brackets. Oh, here is PM, all right? To bracket 50. Okay. All right. So we're going to have these values upon summation. That is by adding all these from here to the end. We're going to have, so we're going to have QDX equals 33721.0148, right? Minus 260.6820px. Then plus adding all those have underlined above, you're going to have 5, 6, 5, 6, 8, 0, 3, 0, 5, 6, 8, 0, 3, 0, 0.5344. And don't forget, we have to group like terms, right? So you're going to have QDX equals 3, 3, 33721.0148, right? Plus 568 plus 568.030.53 0.5344, right? Minus 260.6820px. Px. Okay. So the total give us QDX equals 601.751 0.5492 minus 260.6820 px. This is a derived demand curve, which answers question J. That's the derived demand curve. Okay, so let's move on. The next question is K. So let's go over the demand curve again. I had to substitute the other parameters with variables in the demand equation, right? In the demand equation for J, except the PX, then group like terms. So that's what we have now. All right, so let's go to K. K says sketch the demand curve for Mike Pizza. All right, in the event, so to sketch the demand curve, okay, simple. In the event the question it gives a mark of 1, in the event the question gives this very question, which is a K, gives a mark of 1, assigns a mark of 1 to the K, you only have to do a sketch. Which question number is that? That's K. Sketch the demand curve. So you can just, if it's a mark of 1, you only do this, right? Then write here D. You write here price, quantity. That's for 1 mark. But if the question should say about 3 marks, then or 2 marks, then it means you have to do a little computation somewhere before you draw the graph. So let's assume the question says it's a 2 mark question. So let's say 2 marks. So 2 marks, let me bring down the demand function again. What we just got, which is 601,751 point what? 5492, right? Minus 260. Two six zero. 6820. 260 6820 px, right? So we would say that is, we're going to work at intercept. So let's qdx equals 0, then we find px. So if qdx equals 0, what is px? That's what I simply wrote, or I literally wrote. Let's go on. We're going to have qdx equals, so qdx is 0, sorry. So we're going to have 0 equals 601 75 1.5492 minus 260.6820 6820 px. All right, so what do? We make px the subject. So we're going to have 260 right, 260.6820 px equals 601,751 601,751.5492. So 5492. Okay. Then we divide both sides by 260.6820 over 260.6820. So this cancels this. Px will be equal to, or Px equals all right. So our Px will be equals 2308 2308.37. Let's leave it in two decimal places. Then we write coordinates for it. So the coordinate must always red. I'm using red. The coordinate must always be expressed in the form of x and y. X and y. So in terms of price and quantity, quantity will go for x, price will go for y. So with px equals 2308.37 and k giving us 0, or k which we equated to 0, we are going to have the coordinate as k which is equal to 0, and then the px which is 2308, right, point what? 37. So that's the first coordinate. That's, should the question say it's 2 marks? All right, so this will be our first coordinate. Then we move on to our second coordinate. So the same equation, which is the q dx equals 60,1751.5492. Very good. Minus 260 point 6820 px. So as the first equation, we equated q dx to 0 and found px, right? With this equation, we would equate px to 0, right? So that we will find q dx. So we are going to have q dx equals 601751.5492 minus 260 point 6820 divided by 0. So q dx will be equals to, or equals 601,751.5492. All right, so the coordinates will be, the coordinates should be in the form of x and y, or q and p. Those two should give us the coordinates. So here our q is 601,751.5492, right? Then our coordinates, the other p will be 0. So these are our two coordinates. So to sketch the graph, right? My coordinates are, so coordinates. I'm having first I'm having 601,751.5492 and 0, which is the first coordinate. And the second coordinate is 0, comma, let me see, 2308.37. 2308.37. All right, so let's sketch it. So simply, you can use a ruler and your pencil or pen, your ruler and your pencil particular. Then this will be our demand curve. Demand curve. Then we have 0 here, the origin, you have the price, you have the quantity. So the first coordinate is Q, which is rather on the 0 axis. So Q is on the 0, right? Or Q, rather, sorry, the vertical axis. Q is 0 and price is 2308.37. Then we come to the KO axis. It is P, which is rather 0. It is P, which is rather 0. And the KO's value is and the KO value is 60175.54. That's sufficient. So in the event the question gives a 2 marks, or assigns 2 marks to that very question, you can solve it this way to get the full marks. If it's just a mark, then you have to just do a quick sketch to save time. We'll move on to our next question. We'll finish. The next question is the L. Calculate and interpret the own price elasticity of demand. Okay. So L says we should calculate and interpret. So L. Okay, so the question says we are solving L. Question L. We are solving question L. And question L says we should, this question L says calculate and interpret the own price elasticity of demand. Okay, so L, the formula for the own price elasticity of demand has been stated. And then, which is the own price elasticity into bracket OPE equals dQ dx, right? dQ dx times dQ dx over dpx times px over q dx. Now, so dq dx over dpx is a differentiation. What it means, what the interpretation or how to figure out what this differential or this differentiation approach is talking about is that I should differentiate q dx. That is, I should go to equation q dx and differentiate it. But which term or parameter in equation q dx should I touch or should I differentiate? It is px, so this is px, right? And because the exponent of the px is 1, px is together. We cannot separate the p from the x. The px is together, and they have a common exponent, which is 1, right? So because the exponent is 1, let's assume I'm going to cover the px. When I cover the px, what will I be left with? Minus 260.6820. That'll become the derivative for dq dx over dpx. Then I go and find px over what? Q dx. Px over q dx. What is px? What is px? Now px value in the question is 5. And q dx, we got a value of all right. So from the previous workings, we had a q dx to be 600, 448, point 1392, and together gave us a figure of, so together we had a figure of 0.000008, right? Then maybe 3. That's what we have it. So some people, an optional approach could be that we could use the coordinates, right? The QDX coordinates and the PX coordinate, but preferably we can use the QDX and the price given in the question. Okay, so now we have our DQDX. So we're going to say that OPE is equals minus 26 negative 260.68. There is a 0.6820, right? Times or multiplied by the 0.7 zeros. 1, 2, 3, 4, 5, 6, 7. Sorry. Multiply by 1, 2, 3, 4, 5. Then 8, 3, 3 approximately. So the same here. 1, 2, 3, 4, 5, 8, 3, 3. All right. So we're going to have, by multiplying, we have our own price elasticity, that's the OPE, to be equal to negative 0.12, so 317, let's say 15 approximately. All right, so negative 0.002175. And what do we learn about the when it's an unknown price? We will find the approximate and we would write the absolute. Sorry, we find the absolute figure with 0.0021715. So here we would say that demand is inelastic, right? So demand is inelastic. It's inelastic. All right. So let's move on to question M. We're almost done. Based on the answer, so question M, let me write it here. I'm using this color, I'm using this color. So question M. Based on the answer in L above, right? Based on the answer in L above, comment on the success or failure of a discount sale by the firm designed to increase revenue. Designed to increase revenue. So now, from the L which we just solved, we concluded that demand is inelastic. So if demand is inelastic, the M is saying that the business wants to undertake a discount sale with the intent of increasing revenue. So based on the L, we should comment on the success or failure of the business's policy it wants to undertake. Before I teach this, let me explain something before. This question is usually coming from what is called a TR test. So let me write it somewhere here. I'll clean it anyway. Let me write it below. Let me write it below here. Let me write it below here. TR tests. Okay. Well, let me do it somewhere here. So follow here. I'm going to do TR test here. So the TR test says this, the TR test. Right? We have the type of, let me say the equation for the elasticity. The equation. I'm doing the TR test here. So we have the equation. We have the type, right? We have the pricing policy. Pricing, right? Policy. Then we have the effects, or let me say TR. Then write a TR. So this is TR test. Now watch. When elasticity is more than 1, and we have when elasticity is less than 1, and we have when elasticity is equal to 1. So the type, if elasticity is more than 1, it is called elastic demand. The type of demand is called elastic demand. If it is less than 1, inelastic. Inelastic, when you say something is elastic, it stretches. Inelastic, it cannot be stretched. And E is equals 1 is called unitary, united. So uni, one thing, oneness. So when the business, so let me move this up. Pricing policy. Pricing policy. So when a business is operating, right? When the business is operating and we have an elastic demand, the aim of every business is to increase revenue, have more revenue, right? So it's to increase revenue. The next one is also to increase revenue. But the last one is to my revenue reach its maximum for the last equation. That's a unitary. So if the business aim is to increase revenue for both elastic and inelastic, if it is elastic, right, the business will have to decrease the price, right? The business will have to decrease the price in order to increase revenue. If it is inelastic, the business will have to increase. The business will have to increase revenue, right? In order to, the business will have to increase price to increase revenue. If it's a unitary elastic demand, the pricing policy will remain unchanged, meaning the business will not change the price, it will maintain the same price. Because at that price, it reaches maximum. So if it tends to increase it, it might either lead to losses or surplusage, right? Or yeah. So let's put it that way. So that's how it's going to be. So it's going to be unitary. Unitary. I good. So unitary. Sorry. Unchanged. It's going to be unchanged. Changed. So the price will remain unchanged. So that's it. So there's a pricing policy. So now whenever the type of elasticity of demand is elastic, the business will have to decrease price to increase revenue. So this is the clue, just for you to be able to remember it very, very quickly. Concentrate this side, you must actually know it. But between the pairs here, the inelastic and elastic, if it is inelastic, the aim is to increase. So for the inelastic, we will say inelastic type of demand or inelastic demand, increase price, increase revenue. So over on the total revenue scale or on the side of the total revenue for both elastic and inelastic, they are all increasing, right? But for the elastic demand, if inelastic is increasing price to increase revenue, then the pricing policy will be the opposite side for the elastic, meaning the elastic demand must decrease to increase revenue. So if the inelastic demand wants to decrease revenue, it has to decrease price. Meanwhile, if the elastic demand wants to decrease price, it has to increase revenue. So it's the opposite direction. All right. So now with this total revenue test out of the way, let's come back to our question. Don't forget, from the L, we got that demand is inelastic. And the question is saying, based on the answer in L above, comment on the success or failure of a discount sale by the firm designed to increase revenue. So it's the TR test. So to discount sale means you reduce or decrease the selling price, the total sales, right? And the aim of the business is to increase revenue, right? So it wants to decrease price to increase revenue. But on what basis can the business do that? That is why it's made a reference to the L. And what is there in the L? The L tells us the type of demand. So from the TR test, if the business wants to decrease price to increase revenue, from the TR test, is it appropriate? The TR test is that if the demand is inelastic, for the business to increase revenue, it must increase price. Meanwhile, the business policy is to rather discount or decrease or reduce the price in order to increase revenue. So the question is asking us to comment on the success or failure of this policy, given the inelastic demand in L. So here, what we will say is that the business policy to decrease price to increase revenue will not be successful, right? So the firm's right policy to discount sale. So you can write it well. My board is very slippery. To discount sale to discount sale to discount sale to increase revenue will not be successful. Will not be successful. Will not be successful. This is because demand is inelastic, and the firm must rather increase price to increase revenue. All right, so that's it. Okay. Now, another thing else I wanted to touch is the formula for the own price elasticity. The formula, after that, we'll continue. So, own price elasticity equals, right, dk dx, which is the demand equation, over the px, right? Then you move the px to the right, you bring the q dx down. Okay, so it's very easy as it is. It's very, very easy. So the q dx dpx, then you move the px, then bring the q dx down. That's the formula. All right, let's finish it. We are done. We're almost done. The last question is question, come down, question N. So we finish with M. Question N says, so you calculate the cross price and income elasticity of demand. You calculate the cross price and income elasticity of demand. So that's N. So N, cross price elasticity. So let me use CX and PY to state them. All right. So into bracket CX, and PY. Okay. So CX PY equals DQ DX over, right? The cross price means that we are crossing the, we are comparing the demand, original demand with the dependent variable, which is the QDX or the QDX, with the price of the related commodity, which is more of like the PM. I get it, the PM, not the PS. The PS is Sprite. right, is right. But the substitutory product in the question is the max pizza, right? Then again, we move the PM up over, we bring the QDX down. That's it. So we go to the question, and just as I did earlier, for simplicity purpose, if I'm solving it, I'll be quicker or use other strategy to get the answer. So we will write the QDX here, right? The QDX here over the PX here. So I go back to the data or the information I've written above, the equation, original equation, which is here. This very equation is what I'm referring to. Then I'll search for, you said I should differentiate equation QDX, right? So I'll search for the corresponding variable or parameter which should be actually differentiated in the model. And that variable is the PM, this, right? So this is the variable. And as what we learn is that as the index number is 1, let's assume you're going to cover the PM, right? So as the index number is 1, we will just write the coefficient of the PM as the derivative, right, of the x of the QDX and the PM. So what is the derivative? The derivative for the PM, the coefficient for the PM, which will become the derivative, is 112,6921. 112,6921. 112,6921. 112,6921. Right? Then I also find PM. I'm taking the terms one after the other over Q. I could write everything together, but let me take them one after the other. What is our PM? Our PM was 50. And our QDX, our QDX, we have 600,448. That's 600,448, 1392. 600,448, right? Is it 1692? Let's confirm it. 1392. 1392.1392. So that's going to give us 50 divided by 600,448.1392, which gave us 0.123 4833. Okay, that's quite similar to the first. 3. That's fine. All right. So we come in back to the formula of the cross price, which is CXPY equals, we have 112, 112.6921 multiplied by 0.1234833. So we have 112.6921 times 0.1234833. Okay, that gives us 0.12938. 0.9387. Okay. All right, that's it. Now, if we are to give the interpretation, we will say that because the cross price is positive, both goods are, because the cross price elasticity is positive, both goods are substitutes, right? Both goods are substitutes. That could be the interpretation, or that is the interpretation of this. But let's see what the question says. The question says, calculate the cross price elasticity and income elasticity. Okay, fine. So we're only asked to calculate the cross price. So this is a cross price elasticity. That's it. Our values are quite huge. Now we go to the next, income elasticity. That's our last part of the question. Income elasticity. So income elasticity. Let me use the acronym IE. So the formula will be, since it is divided by, since an income elasticity, don't forget, let's take it out. This is the queen, who is the boss. It will be carried by the person whose name is in. I get it. So here is income elasticity. The type of elasticity is income elasticity. So all the variables in the model, in the demand model, they'll all carry the queen, which is the demand on the dependent variable. So you could remember that when we did the own price, it was dk dx own price, its own price over the dpx, because it's the excess own price which will carry it. So all the elasticities, and a better way to remember or to memorize them is that all the elasticities, always the K comes at the top. If it is the normal demand equation, the K comes, the Q becomes the numerator, which will be carried by the another variable, and that variable's name forms part of the type of elasticity. So what we are working on is called the income elasticity. So which variable will carry the queen is the income that will come down. The first one was own price elasticity. So which variable will carry the queen is the own price, which is part of the equation. The cross price elasticity, which variable will carry the queen? It is the price of the related good, either a substitute or the substitute, mostly. I get it. All right. So we go on to dq dx over dm, right? Then we will multiply, the m goes to the numerator side, then the q dx comes down, q dx. That is it. So let's get the values for these. So again, I'm breaking it down. We can write it dq dx over dm times m over dq dx, or alternatively, we can write it this way, dq dx, right, over dm. Then you can also say m over what? Q dx. It's still multiplication, only that the second I brought the parenthesis. I get the second I brought parenthesis, so can either write out the first or the second, whichever way you write it is correct. They are multiplying. So again, let me take the first multiplier, which is the dq dx over dm. Then I would go straight into the equation, the model, the demand equation, dm. So the dm, you can just write it d as this way, or delta. All right. So I've been writing the delta kind of dm. Okay. So we have equals. Now let's see. So let's go back to the equation. Let's check the coefficient. No, so now we are on the m. Because the m also has an exponent of 1. So we will write the coefficient of m as the derivative for dq dx dm. Okay. So the m is right there here. I'm using brown or gold color. I'm using the gold here. That's the m over there. So we're going to write the coefficient of the m, which is 4.9928 as a derivative. Because the formula says go to equation. There's a formula, dq dx. So go or differentiate equation dq dx. So where do we find equation q dx? That is it here. Another gold on the left in the circle. That's QDX. So this QDX, and then in the QDX, we differentiate particularly the term or the parameter M, right? And when we differentiate the M as a parameter, right, the coefficient is the 4.9928. 4.9928. 4.9928. So 4.9928. That's the derivative. Whenever you differentiate and the exponent has an M, or the exponent is 1, the variable has an exponent of 1, the derivative is the coefficient. So we write everything. Then we have the M over Q dx also. We differentiate. Now M is, I think, 100,000. Yes, 100,000. And the Q dx was 600, 448. 600, 448 points. Six hundred four 1392 points 1392 points 1392. All right. So that gives us 100,000 divided by 600, 448.1392. That gives us the value of 0.1666542. That's sufficient. All right, that's it. So we come back down here and then we plug them in. Now the income elasticity becomes IE equals 4.9928 multiplied by 0.166 0.166542. 542. So we have 4.9928 times 0.166542, which gives us 0.8315. That's sufficient. 0.8315. So if we were to interpret, we would say this good is a normal good because the income elasticity is positive. Right? This good, or the Mike's pizza, is a normal good because the income elasticity is positive. So this is all that answers the question 1 of the tutorial questions for the weekend students. All right.